Hey everyone, and thanks for joining. This is definitely a security talk, so you're not allowed to laugh. This is all very, very serious stuff. So getting started, I wanted to speak to you today about a specific type of vulnerability. And I've been researching a bunch of those vulnerabilities in my day job at Snyk, as well as just weekends. This is fun stuff. But I also do a lot of hacking around just open source general projects, the Node project itself, as in Node Core. So being able to triage vulnerabilities sent to Node Core or to the NPM ecosystem, there's a lot to learn there from a lot of those activities. If you do want to join any of those, there's like a lot of other speakers who has been here today from the Node project. There's going to be a bunch of talks around Node Core as a project with core contributors from Israel here. So if you do get excited and want to join in, this is very free, collaborative, and open. And we'd love to have you join that. Beyond that, I do work at Snyk, where we build developer-first security tools. So making security accessible to developers in your IDE, in your code, in your CLIs. I'll show some of that maybe at the end of it to give you a glimpse of what the future looks like. So today, my story starts with how at one point in time I had to make a really hard decision as a developer. I had to decide whether I should use ChatGPT or write the code myself, which I guess a lot of us kind of like relate to this in our day-to-days. So as an experienced and developer as I am, I have went with the hard decision of course, calling ChatGPT for it. And I started very openly, very fun, enthusiastic, so the robots like me and want to help me. They kind of had this attitude, which is like, I remember that I am the human in this place, and continued with my instructions. And so I asked it, this is real ChatGPT interaction I had, to create a post endpoint for a Fastify web application. I gave it the actual route and expected back to get a Fastify upload application. It did pretty well on its first try. And if you read through this code, it's very readable, very concise as well. It looks pretty great. There's one thing that is kind of out of the ordinary here, which is it doesn't really has an upload file.mv in it. So there's no need to reference that because that does not exist in the code anywhere. It just made it up. So it did correct it once I asked it to correct it. And there we go. We have, if you take that and do what all developers do, right? Post it to VS Code or IntelliJ, whatever you feel comfortable with, push it to production, and code just burns. Because there's an actual security vulnerability in that code base, which ChatGPT responded with. The security vulnerability is showing up right here. There's a path traversal issue here that would allow any developer to either do write or read anywhere else on my disk, because this is not concatenating file paths correctly. But why is this actually happening is what I want to talk about today. So let's demystify first. What is this type of file path and path traversal vulnerability? Well, the dictionary definition tells us that as developers, if we do not use correct security controls, like, for example, sanitizing strings or putting validations in place and all of those kind of controls, then input from users in the context of file paths, such as those given to us as post endpoints or URLs, could end up leaking into business logic code that uses sensitive operations like file system APIs, all of those things. When that happens, we have this vulnerability of a path traversal. So a path beyond what we were supposed to make accessible to the end user is now made accessible. Let's see this in practice. Let's say you built a Node application based on Express or Fastify or whatever you want. And maybe someone gave you that input to access a file with a .. So potentially they're trying to get outside the root directory of what you defined, /public or whatever that is. If they send that request and you have a vulnerable server to path traversal, they essentially get access to whatever they want if that path exists on disk. Now, I'm pretty sure no one here saves their credentials on config.js, right? Like everyone just use secure storage. So all of this data is now made accessible to someone. And it might seem at first that Path Traversal is very basic and very rudimentary to an extent as well. But if you think about it, it's really wide-reaching and very impactful. Because once I'm able to access files and read them, not even write to them, but just read those files, any place arbitrary code files that I want on your disk, I can access those config.json, those environment variables, node modules where you have maybe intellectual property that I don't have access to outside of it. I can access your application dependencies as well and see if there's like an outdated or vulnerable dependency. I can then chain that vulnerability and actually escalate the attack to something much, much bigger. So let's see some path traversals in the wild before we dive into how Node, the core runtime, was once vulnerable to that, maybe exploit that, as well as other packages. Well, if you come to think of it, again, this seems like a very rudimentary thing. But if you think of other web servers like HTTP, the Apache HTTP server software, which existed for decades and obviously has very brilliant developers working on building this, if you think about it a bit more, their core functionality in a dedicated web server is really to handle files and file paths and URLs. And even there, they get it wrong sometimes. It is actually so hard to fix and find those vulnerabilities that this CVE from not a long time ago impacted a path traversal, but it happened because of an incomplete fix that was applied to the code base of a previous vulnerability. In fact, exploiting it is, as we said, pretty simple. This is a payload you could use today to exploit that version of HTTP. And you might think, well, where do you find all of these, darknet payloads? No, I don't go to the darknets to find them. I just go to Twitter, which is usually a dumpster fire for everything InfoSec related. And people just share this openly. In fact, if you look closely, and I'm happy to share the slides afterwards with a tweet, this is actually even escalated attack into code execution beyond the path traversal for that vulnerable Apache server. So at first, when you are bringing this down now to Node as our own day-to-day development task, you might think that all of those, path join we use regularly, maybe resolve, maybe normalize. A lot of static web servers use those as definitely things like express static, 11t, Astro. They handle those things a lot. But if you come to think for a second, what are the actual differences between all of them? There are very nuanced differences that make the entire stack sometimes just crash in terms of being vulnerable to those path traversal attacks. And you'd think also secure coding is easy, right? We've learned development, we've learned performance, like, hey, let's just do secure coding, let's just practice it. It's not so easy. So let's start our journey with diving into those vulnerability cases. First off, we'll see an actual vulnerable NPM package. Some of you might have heard of. It has a lot of downloads, as you can see, about 500,000 weekly of them, so definitely millions over a month period. Maybe you know this package called ST, which is usually used as a middleware to Express to serve static files. It's very simple. You simply provide it, as we said, as a middleware with your public directory on disk, and then the public endpoint where to make it available, such as the /public endpoint. And at that point in time, it makes static files available on that route. Pretty simple. Maybe you try to send it this .. and you try to hack an app based on this knowledge already, which, by the way, congratulations, you're all now semi-hackers at some point. Maybe it doesn't work. Why doesn't it work? Now it's interesting. Let's dive in and debug a bit of how the ST module actually works. So here's real code. We're going to act like a debugger here and dive into one of those functions that handles this input. It has this get path function that it exports outside to the Express middleware and as part of its logic. And it gets this U variable, which is our URL. So someone tried to access /public .. package.json. At that point, it runs this URL.parsing logic with some extra sanitization of regular expression for ROG, / characters and all of those. And it gives this data as another input to normalize. Path normalize is, as you've seen, another path core module function that allows us to normalize strings. What this actually means is, if you are aware of what eval is in JavaScript, so this is kind of like what normalize does to strings. It normalizes the string and sort of evaluates it. If there's like a dot dot slash, it will try to evaluate what that means and gives you a new path. So now this path becomes the following. Now we're actually understanding that they're trying to access slash package.json. So there's now another endpointer called with this conditional, and this code here actually checks if the beginning of the path is the same as the one provided with the strict URL. Since they're incorrect, and the URL should be slash public slash something to begin with, which is not, because we've normalized the string and understand what it actually goes for, we can understand this is not something they should access and return false, and that's why it didn't work. But luckily for us, there are other ways to bypass this. The web has this concept of URL encoding. If you want to provide web servers with sort of explicit string characters like dot dot or slash, you sometimes have slash has its own meaning as a separator in the parameters. And so to that extent, you have to encode it if that is part of an actual string that you want to pass. To that extent, we can also take those dot dot characters and exploit them to something like %to e, which is what it means. So we're going to go back into ST and see how it behaves. So we go through this whole dance of providing it with slash public, slash %to e package JSON. We do all of this dance with URL parse, give it to normalize. But what does normalize do at this point? Nothing. Because basically there's nothing to normalize. It's not a dot. It's a %to e, and that doesn't mean anything in terms of paths. So this continues, but now we're discovering new code flows in this function. Now there's a code that does decode URL, URI component, which means it's gonna decode the URL from what we just gave it. Great. That means we're back to what we aimed to be at the beginning, which is dot dot. Now, the next part is where everything happens, right? The path is concatenated using path join at the wrong point in time with a bad validation and handed to us. And so if you were given %to e to this vulnerable version of ST, this is how you would hack it for Path Traversal. That's all you have to do, really. So I think more interesting, or perhaps maybe at the same level of interest, right? You're curious, like what fixes it? What sort of fix did the maintainers apply to actually mitigate this? Not just learning about the vulnerability, but how to fix that. So you could see this is the diff, part of the diff that actually relates to fixing this vulnerability. And if you look closely at what happens there, beyond the regular expressions, which to this point actually provide the same decode URI component functionality to an extent, right? Just using regular expressions. But you would notice that the fix is really lying in the fact that the order of the functions is what matters here. We have to first decode it and then normalize it. And this is why practicing secure coding sometimes looks, even for this kind of vulnerabilities, very basic, but we can very much have those really huge mistakes. So you'd want to first decode the URLs. You then maybe, this really depends on the business logic, like path normalize or end concatenation. Maybe you have to do a validation like path relative to say any paths provided to me have to be relative to a specific path on disk, right? Maybe you don't want to do that. Maybe you just really build a very generic HTTP server that accesses everything from /etc to following symlinks. But those are probably not the actual use cases. And so please take this in mind. Now, we've talked about an example with a vulnerable NPM package, and I want to take you to like a whole different case of path traversals impacting us as developers, but in a whole different concept. What if our VS Code IDE was somehow made possible to target us and make us vulnerable to people stealing data from our machines just because we use VS Code? So VS Code is pretty cool. It has extensions. This is one of them. It's called Open in Default Browser. It literally opens files in your default browser. So you could see there's like a right click on a file, click it, gets opened. I guess makes sense. It, again, seems basic and whatever, but this gets downloaded for like almost 1 million users who installed it. And I guess at some point in time, this was useful, maybe these days as well. But this extension, specifically in the way it works, it has to spin off a web server that runs locally and serves you those things like index.html and other things as well. And the way that it does that has vulnerabilities in it. I want to show you how that manifests. So I have a video here where on the left side, you see the actual VS Code in action. On the right side, you see a browser. And this is going to be a video where we encompass both the victim here with the VS Code and the browser, as well as the attacker, which you're going to see several terminals open up in a second. And at first, it starts off with showing you how this actually works. So here's an HTML file. Literally click that open in default browser, and you see the example. So far, so good. Now, the attacker spins off 3 terminals in which they serve the file themselves, their own endpoint that they want you as a developer, as a victim who runs VS Code, to click and be vulnerable to this attack. And they use a bunch of ngrok and a bunch of other things to serve this. And to the left, which is granted very small, but you'll see the change in a second, we see that the attacker ran the ls command, and they have 2 files existing. And the end goal is to steal the secret keys file that exists on the developer machine. And then at the end, we want to see there's like a new file existing there. And so all we really need to do to trick anyone with VS Code open and that extension installed is just to send them one file. The moment they click on it, we have access to, we actually have downloaded any file we wanted from their machine. I just clicked on it now in that video. You see it says nothing to see here. It actually de-downloads something automatically, and then the attacker shows us that there's a new keys.txt file on their machine transferred. This is all due to the fact that this extension, supposed to be useful, was coded in an incorrect manner, not using security best practices, and it had been vulnerable to Path Traversal. So it means if you used VS Code, if you run this extension, you run a vulnerable version of it, hopefully not, you are susceptible to this sort of attack. Here is the code of the VS Code extension called Open in Default Browser. Hopefully at this point you understand what's going not very well here. We just take input, even though we decode it, and we serve it. We concatenate the actual string. There's no validation done, there's no normalization. Plainly, whatever file you want, we create the paths and send it to you. Great. If you think about it for a second, this kind of attack isn't that simple to replicate due to cores and uses a bunch of tricks like iframes to isolate the whole thing and make it a really one-click attack that encompasses the whole exploitation process. There's a whole deep dive into what this actually requires and how this actually works. So if you wanted to deep dive into more of like the cores and how this whole thing works, highly recommend going into this deep dive blog. Plus, there's other examples of and references of other extensions that were vulnerable and allow different execution points, not just Path Traversal, but other vulnerability types. So I guess almost at the end of it, I saved the best for last. Not a long one, but I think an interesting one. And that would be the Node.js runtime, which we talked a lot of before here. Eric talked about it from the viewpoint of how to build and the engine behind the scenes, and Colin talked about it from the release standpoint and mentioned the security release that was just sent out. And I think a lot of time when we think about Node.js and updating to version 18 and 20 and the next up, you think in terms of features, right? Which is kind of like what Colin did, right? We talked about all of those features becoming available, the assertions, all of those, the test framework built in, all of those features. You don't really think about upgrading because you want to be on the latest security features, on the latest security fixes, which are not always, the new major versions, but sometimes the minor or patch. And so here is one vulnerability where at one point in time, Node was actually vulnerable to Path Traversal. It was a version of the runtime, not that long ago, but enough time that I can talk about it openly without putting a lot of users at risk and jeopardizing, a bunch of you. So hopefully you don't run this version, which we'll see in a second in production. And I won't go through the code because this is just like the JavaScript version of it from what we saw before in Node core that essentially it lies within the core path module. And then the path module acts differently and exposes paths in a different way than it should. What this actually means is that if you try to use normalize or resolve or all of those kind of functions, you'd expect, that kind of input to resolve to, the expected kster / etc password, and it doesn't. It actually behaves differently. That does allow for path traversal. And really anything that you would think in terms of applying secure coding in your code or in the dependencies that you have is just not enough, because at this point, it's the runtime itself that is vulnerable. And since those functions use it in a very specific, those modules, like Express, right, that serves static files here, uses the core path module in a specific way, creates the vulnerability. So I wanted to take a different way to demonstrate this attack, which is not to, the whole debugger game, but show you how easily attackers are able to just leverage tool, not just us as developers, but attackers leverage those automated tools too to go ahead and exploit victims. So here's what we're going to do. Hopefully I still have my Docker session running here, and it has a simple endpoint for a logic of uploading files, but we don't really care about all of that. You could just see that at the end it has this app use public and just uses Express, and this is the whole thing that it does. So it runs this thing. And to, with that knowledge, I want to show you something else. There's a tool called .pun, which is kind of like a decade old or maybe more. What it does, it's an automated offensive security tool that allows researchers, developers, you can put it in your CI, which is something I hear people do sometimes, and give it a URL, and it will go ahead and try different sets of permutations of all of those URL encoding to access paths and files on any web server that potentially exposes static files or potentially vulnerable to path traversal. So what I'm going to do here is give it this input, which tells it to use the HTTP URL module, tells it to look for the keyword localhost and this specific file. And if you think about it, the fact that we actually tell it to use a specific keywords is to eliminate false positives, because many mitigation security tools like firewalls or others would actually respond with dummy data to fool us into thinking that they are vulnerable. I think this should be my IP here working on this in this room. I give it the traversal key, which is it knows to replace those, and it tells me it's ready. All I have to do is literally press return, and it's going to go and run different sets of permutations of URL encoding that apply to Mac OS and Windows and Linux, and the fact that it's in probably thousands of different ways to access file paths. Now, this takes a while, so not that long, but I'm going to stop it here because I did it before in the speaker's room. And you can see that I actually it stops, by the way, it breaks on the first vulnerable path. And all I really have to do is take the path that it found. All the other permutations didn't work, but this one did, and run it. And now I am able to access, for example, this etc host file on the container. I think I have an example here which shows us being able to access the server.js that you saw the code for a minute ago over here running inside a container. So it shows you how attackers are able to just automate their way into leveraging path traversal attacks. Doesn't matter if your node runtime is vulnerable or something else is vulnerable, like your NPM or your dependencies or your own code, you're at risk. So we saw how this happens. This is from back at 2017, and Node version 8.5.0 was vulnerable to that. As you can imagine, there are many releases back in even in this year of security updates that Node released. So please stay up to date. We can't really do this kind of education for every vulnerability that gets found or released, because indeed that would or might put users at risk, and many of them are disclosed in a very responsible manner to not put users at risk. But it shows you why you should keep up to date. So let's summarize this. If you'd ask me what I thought about path traversal vulnerabilities, is the following. It's the fact that if our applications are built in an insecure manner, as in there's like config.js file or end file or config.json or whatever you use, then on disk available to the application, then it makes the attack surface now grow a bit bigger because I can access them, right? If your application is built in an insecure way, it doesn't have to be vulnerable to begin with, but if there's a vulnerability that just gets found at one point, then the fact that there's a lot of other things that are not entirely built well in a secure manner just compounds the impact. And we talked about the fact that this actually happens in your code, in dependencies, runtime. I actually had different versions of those slides showing how there are path traversal vulnerabilities in routers and printers, and people just exploit them. Remember, it's really easy to confuse those file paths, path resolve, path normalize, what they actually mean. So you have to understand what they mean and in which order they actually should be used. And as we said, this is basically a doorway in for someone, right? Whatever that is, they can actually escalate the attack from a path traversal to then code execution and exfiltrating data from like database credentials from your applications. To close it up with another maybe takeaway here is the following. I took the version of the ST module, that version of code that was vulnerable. You can see it to the right as a copy-paste of the module. You can even see the actual file path. And I actually used that in an actual route, as if I used the module directly. And the moment that I did that, and the fact that I had a VS Code extension here open from Snyk, allows me to see that there's like a linter, unsanitized input that actually flows into my app. So it actually identified at code time when I saved the file and sent it to get tested. I get immediate response to know that this is vulnerable and I should maybe fix my insecure code. So hopefully, whether you use Snyk or something else, you do apply those secure coding conventions. Snyk is free and available. If you have any questions about that or how to use it, just search for and download it. But otherwise, I'm here, happy to chat about it, and stay secure. Thank you very much.